In this lecture, we are going to go over how to complete the binomial distribution portion of the project workbook. Also, just letting you all know, the project workbook, you can download it below. Based on the previous lectures, I did actually update the document a little bit. I made it a little bit easier to know exactly what to do based on just the instructions that are written there. So be aware of that. So if you want to download the new version, it's not that there's really anything different that you have to do. It's just a little bit more thorough, gives you a little bit more information, um, and just sets it up a little bit better, if you will. So we're going to take a look right here. We've got the project data. Once again, this project data is the revenue of fast-growing companies, of the fastest-growing companies in the United States, and also the states in which they reside. And I believe there are, let's see here, somewhere in the ballpark of around 60,000 records, 60,206 records. And so we're going to look at a binomial probability distribution, how to use that in order to be able to gain a little bit more insight. So, in one of our last lectures, we took a look at state and revenue variables. And with the state and revenue variables, we specifically are interested in knowing what is the probability of a company randomly being from Texas or from a low frequency state. We've got the classical probability and the empirical probability here. Then we are also interested in whether or not their revenue is between 2 million up to 4 million or greater than 40 million. Which once again, we've got the empirical probability and the classical probability right there. So I actually need this information. Note it's in the classical and empirical probability section. So I'm going to go ahead and just grab this. I'm going to press Control C, and I'm going to go right next door to the binomial probability distribution. And let's see here. I'm going to put it right down here. So I've got some information down here, and now I need to make a decision. We are going to look at we're going to look at one of the outcomes from here, and then we're also going to look at one of the outcomes from here, and we're going to conduct a binomial probability distribution based on that. So I want to know, what is the probability if I randomly choose one company? This right here, once again, is classical, and this is empirical. And anytime that we have empirical probability, it is always better to use the empirical probability. So I just want to really emphasize that if you have empirical probability, you should definitely use that before you use classical. So I'm going to look at empirical probability specifically for what is the probability of me randomly selecting a company and it being from a low frequency state. So I'm going to copy this right here, and I'm going to put it, what is the, notice it says, okay, this is everything that you're going to be doing. And right down here, we're going to actually put it in there, and this is literally just these 16 slots is all that you have to do. And you might have a document in front of you that only has 6 slots for each one of them. That's fine, you can just do that. It's not that you have to do any extra work, it's just I give you an extra place to put down some information to make sure that you don't make an error. So if you look at this, you'll notice there's a slight difference, and it kind of puts it in a slightly different order. But as long as you just do the complete the document I gave you, you'll be fine. So it says right up here, you're going to examine an additional sample. So you already have a sample. And so we've got the 60,000. We've got the 60,000 there. And we are going to be doing, we are going to be assessing an additional sample size, or an additional sample, or we're going to be taking a sample from that population of either 20, 200, or 2,000, depending on what we want to do. It really doesn't matter. I mean, we can do 2,000. I think I'm just going to do 200. And yeah, so I'm going to take a sample of 200, and I want to know what is the probability of getting these getting a certain number of states from this sample that are in the low frequency. Okay, so I'm going to press Control C. I'm going to put this right here, and I'm going to say, okay, what is a class that you're deeming as a success? The truth is I want to keep the low frequency states low. I want to, I want to examine these states, but more specifically, I want to examine the states that have the highest frequencies. And so I'm kind of concerned about, hey, if I am doing this assessment, what's the probability of me having a certain threshold of low frequency states? And so even though the success is the high frequency, even though what I really want is a high frequency state, what I'm assessing and what I'm deeming as a success is me pulling a low frequency state. And so I've got a low frequency state there. And you've got the classical and empirical, and what we care about is the empirical. So I'm going to copy this, and I'm going to say, what is the empirical probability of success of each trial? I'm going to put it right there. And then what is the total number of trials? I'm going to pull 200. And of that 200, I want to know what is the most likely single outcome. And so in order to be able to do this, all that you have to do is do equals 200 multiplied by the probability of success at each trial. And so the most likely single outcome is going to be 33. That's going to be the most likely single outcome because it's just round it, round the number, round round the results either up or down, whatever it's closest to. So that's the most likely outcome, that there will be 33 low frequency states if I survey 200. And then what's the minimum number of successes that I need? I really want, let's just say, I really want 160. I really want 160 states that are representative from high frequency states. So the minimum number of successes that I need, let's see here. That's kind of complicated. Well, it's actually the maximum number is, I want that 40. I want 40 or less. So it would actually be slightly different the way that this is set up. And so I'm actually going to, for our purposes, I'm going to say, let's see here. Yeah, 40. What is the minimum number of successes that you need? 40. What is the probability of the exactly the number of successes needed? So I'm going to do equals a binomial distribution, and the number of successes is 40. The number of trials is 200. The probability of success at each trial is 0.16668. And whether or not it's cumulative, in other words, do I want 40 or less, or do I want just 40? In this case, I want just 40, so I'm going to put false. And so the probability of me having just 40 is 0.033127. Okay? So that is the binomial probability distribution. It's saying the probability of, if I pull 200 states, the probability of me having exactly 40 states being from low frequency states is about a 3% probability. And so now I want to know, what is the cumulative probability of 0 successes all the way up to 40. So you use the same exact formula, so I'm just going to do equals binomial distribution. The number of successes is 40, once again. Number of trials is still 200. The probability of success at each trial is still 0.1668. And then instead of false, I'm going to put true, because I want 40 or less. In other words, 0 all the way up to 40. And you'll notice that there is a 90% probability that when I pull a sample of 200, when I pull a sample of 200, there's a 90% probability that 40 or less states will be low frequency states. Now the question is what is the probability of success of 10% below or 10% above the minimum number of needed success? Okay, So in order to do this, 10% below or 10% above. Um, let's see here. The minimum number needed of successes is 40. Okay, so what's 10% of 40? That's going to be 4. So what we're talking about is a range between 36 and 44, because 10% below is 36, 10% above is 44. So in order to do this, we're going to use a slightly different formula. We're going to do equals binomial distribution range, and the number of trials is still going to be 200. The probability of success at each trial is still going to be 0.1668. And then the number of successes, the first one is going to be the lower value. So that's going to be 36, which is 10% below. And then the upper one is going to be 44, which is going to be 10% above. And what that says is there is a 31.6% probability that it is going to fall between 36 and 44. 36 and 44, that there will be between 36 to 44 states that are low frequency states in that sample. And we can do the same exact thing down here. What is the class that you're deeming as a success? This time I want you to do one of the quantitative ones. So I'm going to copy this. I'm going to put that right there, and then the empirical probability, and I'm going to breeze through this really fast. Then the total number of trials, once again 200. Most likely single outcome equals the empirical probability multiplied by the number of trials. And then I'm going to do, let's do this, round, comma. So I just rounded it. What is the minimum number of successes that you need? I'm going to go with, once again, 40. What is the probability of exactly the minimum number of successes that you need? So I'm going to do equals binomial probability distribution, or binomial dist. Number of successes is 40. Trials is 200. Probability is 0.17. Whoops. And then, once again, false. And then this is the cumulative one again, so equals binomial number of successes, 40, trials 200, probability of success, and then now we're going to put true. And then last but not least, the probability between 36 and 44 again. So equals the range. Trials is still 200. Probability of success is right there. Number of successes, the first one is going to be 36, which is the lower value, and then 44 again. And so that's the probability of having that range of successes. What does this all really mean? Let's take a look at this for a minute. This is saying that the outcome that we want, the target outcome that we want, if we pull 200 random samples, or 200 random observations, right up here, having 40 or less low frequency states, we've got a 90% probability, 90.9% probability that this is going to happen. And then once again, if we want to know what is the probability that 40 or less states or companies with revenue greater than 40 million are going to be polled, we've got an 82.24% probability that that's going to happen. So I want to show you this right here. This is why we use empirical versus classical. Wrap. There we go. So I put together this fun little document where you can actually see all the individual observations. So we're going to look at the empirical probability of Texas. We didn't look at Texas before, but we're going to look at Texas now. What is the probability that an observation is going to come from the state of Texas? So I'm going to put right here. So this is the classical probability. So I'm going to put what is the classical probability of success? I've got it right there. And then what is the empirical probability of success? I'm going to put that right there. Still, number of trials is 200. And then over here, I want you guys to see this is the number of successes. So as you go down, you can see these are actually probabilities. Every single last one of these are probabilities. They're either cumulative probabilities or they are probabilities of a single event. And these right here are classical, and then these are empirical. And so you can see that there is a definite difference between these. So for instance, taking a look at the number of successes, you'll see that, let's see here, what is the most likely outcome? Let's click right there, or let me just hover over that. So that's 9. Coming right here, is that the most likely outcome? That is the most likely outcome for classical probability. So looking at classical probability, you'll see, okay, they're saying that that there is most likely going to be 9 observations that are from the state of Texas. 9 observations that are from the state of Texas. However, and so that's saying that is the most probable outcome. And then if you come over here to empirical probability, it's slightly different. Let's see here, what is the most probable outcome? And that is going to be 12. So taking a look right there, and if we hover over this, you'll see it should say, hold on. I guess I can't read. Hold on, let me zoom in. My eyes are a little bad. Okay, sorry about that. I don't know why I said 12. So coming down here, you'll notice that it keeps on going up and up and up until you get to 16. So 16 is the most probable outcome right here, and you could also get that just by doing equals 0.0815 multiplied by 200, and that'll give you 16.29, or just round it down to 16. And I'm not sure. Oh yeah, 0.16. There we go. Before I hovered over it and it said 17, I was really confused. So that is each one of these is the probability. Each one of these is the probability of a very specific number of successes. So this right here is the probability that you run 200 trials and you have exactly 0 successes. This right here is the probability of running 200 trials and you have exactly 1 success. In other words, you pull 200 states and only one of them is from Texas. And so each one of these, because it's a discrete probability, each discrete outcome has its own probability associated with it. Same thing right over here. So this is classical, this is empirical. Okay, so each one of these has their own discrete probability. And then each one of these dots represents a particular outcome. Now, it's not super important that you know how to make this, and you don't even have to make it for the project. This is just a visualization for you to help to really understand what's going on. Additionally, this is the probability of success at each trial for cumulative. So this is the classical probability, and this is the, so hold on. This should say empirical probability. Empirical cumulative. That is the empirical cumulative. Now, what happens if I were to change the probability of success at each trial a bit? And you'll notice 0.2. That changes a lot, right? It says, okay, here is the classical probability, and then here's the empirical probability. And so you can definitely see how different it is when you have the actual empirical probability. And so it really does make a big difference when you have the empirical probability. It's really important to use that because it is a lot more accurate. And so once again, each one of these dots represents a particular outcome, and the probability associated with those outcomes. And the probability is on the y-axis. Then on the y-axis here, this is the probability of this particular outcome or less. Okay, or this particular outcome or less. So that's saying that 0.4. 0.4 is the probability of you having 38 states from Texas or less. So anywhere between 0 to 38 states, the probability of that is 0.4 if the probability of a state being from, or a state of Texas, of you choosing Texas, or a company being from Texas is 0.2, then that's what that would be. Once again, you don't have to do this this right hand side. It's just a visualization to help you to kind of understand what's going on a little bit more. But what I do want you to do is this left hand side. All that you technically have to do is these 16, or in your case, it might only be 12. And so just make sure that you do that. And then last but not least, what I want you to do is dig deeper, find more information, find articles, find whatever it is that you can out there on the World Wide Web that really helps you to understand your data set more and helps you to connect with the purpose of your client more. So please be aware of that and work on that. That's the last thing that you have to do, and I want you to write 2 paragraphs about that. I'll give you, well, you're going to submit this document, and so just kind of do one of these things where you highlight a section and you can go to home and merge fields, and you can put 1 paragraph right there, and then home merge fields. So just put the information that you have, you know, the data set, the link, you know, tell me what it is, what did you find, and then write a paragraph about it. And then I want you to, if you can, attach a document of what you found. So that's the long and short of that, and I think that's pretty much it. Hope this is beneficial for you guys, and that this particular unit was a little bit more straightforward and easy to finish compared to the last. Thanks.